My name is Alessandro Ciampechini. I'm an energy consultant here at the Carbon Trust, and I'll be your presenter today of this technical webinar on motor and drives. What we are going to do today is to give you an introduction of motors and drives. I'm going through an overview of the technology, and obviously focus will be on the main opportunities to save energy in these fields. Obviously, a particular focus would be on variable speed drives and inverters, on motors efficiency, and also on how to implement and how to set a motor management policy at your organization. And also I give you some overview of the Green Business Fund and what are the opportunities of the Green Business Fund. Who we are. Carbon Trust is a not-for-profit organization with a mission to accelerate the move to a sustainable low-carbon economy. Essentially, we are independent expert on carbon reduction and resource and energy efficiency, and we reinvest our surplus from our commercial activities into our mission. Basically, we operate in 3 different fields. We give advice to businesses, governments, and public sector on opportunities for a low-carbon world. We measure and certify footprint of organization, products, and services. And also, we developed, we study and deploy low-carbon technology and energy solutions. Going back to the webinar itself, the objective of this webinar is to become more familiar with the technology, especially on motor types and their application, how to better use electric motors, to identify opportunities for energy savings in motor system, whatever motor system you might have, provide you with a practical understanding of motor management policies, and obviously become more aware of the whole life cycle course of a motor that in most of cases can influence your choice to replace the motor or just maybe repair it. And also I'll give you a methodology or a starting point for methodology to assess the condition and performance of your motor systems. Just as a starting data, we can see that globally around the world, electric motors account for 40% of the whole electricity consumption. This might sound quite shocking, but if we think about all the application where you can see an electric motor going from compressed air, heating, cooling, ventilation, pumping system, and obviously all the industrial motors, we can see that they account for 40% of the energy consumption. And if we look at the UK industry, electric motor account for 2/3 of the entire industrial energy consumption. So I think it's worth looking carefully at any potential opportunities to save energy on electric motors. Just to give you an overview of a typical electric motor, you can see the template in the slide. A typical template of an electric motor, you can see here that it shows the efficiency class of the motor. Obviously, you can see the power of the motor, the voltage of the motor, what's the speed that the motor is allowed to run, IP protection, power factor, rated amps, and main supply frequency. So any and every motor that you might have, and you might have looked already, has got this template on it. Obviously, motors come with standard size and ratings, as you might know, and obviously there's always a distinction between AC motor, alternating electric current motors, and DC motors that use direct current to produce mechanical power. There's always a distinction. This is the main distinction between the two types of motors. An important role in the technology is obviously on variable speed drives. Essentially, a variable speed drive is able to change frequency and speed of the motor. This can go from a typical low load, even 20-30%, to can go up to 120% of the full rated speed. And also we can see that even up to 150 rated torque can be achieved at reduced speed. We'll give you an overview of the inverters and variable speed drives later on. Also, before starting on potential energy savings, we need to take into account what are the typical motor losses in a typical device. Like in this slide, we've got a typical fan application where we can see that from the electricity input to the final energy usage, we see different types of losses, like the drive itself, the motor losses, so mechanical losses, and obviously there could be some transfer system losses, and obviously the fan itself has got comes with losses. So we can see that in this example, like just 57% is useful energy if we do the comparison between the final output and the electricity input. This is very important to then find out what are the opportunities to save energy. Obviously, the very first starting point to save energy on motors application is to see and to minimize the usage of any motor. Often switch-off policies and stop-start controls are the most cost-effective actions to be taken. Obviously, when we look at the industrial field, manual switching off always needs to take into account safety, risk, and procedures and instruction before taking any action. Some other times it's sensible to use automatic switch off devices to just sense the load of in a particular application, and obviously, and then managing the motor operating hours just by default using those controls. A typical example could be some timers on ventilation, some other temperatures control, or on pumping system, any other pressure controls. Obviously, in some other applications, like, as I say, pumps and fan, we can minimize the demand, and we can optimize the process just by reducing operating set points, and also, as I was saying before, changing temperature and pressure settings. This is particularly important on fan and pumping application. As we can see on the picture, we can see that point 1 is running at a more efficiency level than point 2, just changing the operating setting of this pump. Sometimes we just need just a little adjustment on the flow rate on the total head to achieve good energy savings. Obviously, looking at new applications, it's very important to have a good design and an optimized design of the new device that you need to install or you need to purchase for the application. Again, designing and choosing the right product, the right device, and can lead to an efficiency, a good efficiency over the whole life cycle course of the motor. That could be 20, 25 years in some cases. Obviously, as I said before, variable speed drives are very important to achieve energy savings, because obviously they can adjust the speed of the motor to your demand by equipping them with a variable speed drive. Typical applications that you might know are on fans, pumps, compressors, conveyors, mills and mixers, and many others in the industrial and manufacturing fields. Obviously, there are not just benefits coming from the speed of the motor, but there could be some other additional benefits, like a better and improved control of the process, of the industrial process, and you can achieve the ability to better control more than a motor at a time. Some other devices like soft starters are very important, because obviously they reduce your starting point, your starting current, so you achieve savings as soon as you switch on your device, your motor. And obviously another field to look at is the motor efficiency that classifies motors into 3 different categories that we're going to look just now. Going back to the variable speed drives, as I said before, there are pumping and fan application. On this slide, you can see 2 typical applications. On the left side, we've got the pumping application. So you can see how much energy can be saved if we compare the fixed speed pumping system against the application with a variable speed drive. This amount of energy obviously can be saved just if the application allows you to reduce your flow rate. If you have to use your motor at full speed, it might not be worth looking at variable speed drives. And in some cases, if you're using your motor at full speed, 100% load, could be even more energy consuming. But obviously, the big benefit from using variable speed drives is that there is a cubic relation between power and frequency. So you can save up to 50% of energy just by reducing your fan or pump speed by just 20%. So it works in the same way, even if it's pumping system or fan system, as you can see on the right hand side. So even on fans application, you can save an important amount of energy by reducing by 20-25% your flow rate of the motor. Here I've got an application case study that we went through the Green Business Fund. This project was about looking at a 22 kilowatt motor. In this case, we just seen that the actual absorbed power was around 15 kilowatts, and given the existing energy consumption of around 91 kilowatt hours per year and 8,150 pounds spent, we've just seen that by recommending and by to install a variable speed drive on this application that allows to run the motor for 6% of the time at 25 flow reduction. We've seen that there is around 2,800 pounds savings per year. That essentially, going for an investment of 5,000 pounds and a capital contribution given by the Green Business Fund, 15%, as we're going to see all the details afterwards. 750, 100 pounds. The payback, the net payback, is just over a year and a half. So in cases where the flow of the pumping system, or again of the fan system, can be reduced, a variable speed drive is always could be always a good way to have good savings and obviously a good payback. We've got many other case studies in other different applications, like compressed air through the Green Business Fund. We went through an upgrade of a fixed speed 22 kilowatt compressor with a 30 kilowatt variable speed machine, and in this case the payback was just around 20.5 years. Obviously, the benefit to apply a variable speed compressor was that obviously the demand was not constant, so variable speed drive machine allows the client to adjust the air that's produced by the compressor depending on the demand, the industrial demand of the site. Another case study that we've got here is about 200 kilowatt motors fans that have been fitted with 2 inverters, and the payback here has been really good, in the region of 1.2 years. So again, if we look at the size of these motors, so 200 kilowatt, and there was an opportunity to save energy, to reduce the speed, the payback is always extremely good. Another thing that it's very important when we talk about motors is the motor efficiency. The motor efficiency obviously reflects how efficient is the motor to convert electricity into mechanical power. Obviously, all motors are classified by their efficiency. There are 2 main ways to classify motors: the IEC and the European CEM EP. That essentially, it's slightly different, but most of them overlap. So in terms of IEC, we've got the IE 3, 2, and 1, and the EFF 1, 2, and 3 from the European classification. And we can see from the chart on the right that the efficiency of the motor is very important, even especially if we look at fairly small size of those motors, like below a rated output of 30 kilowatts. We can see there's a considerable gap among the 3 categories of efficiency. We also need to take into account that the legislation behind the efficiency of the motor. We see that like from January 2017, motors with an output between 0.75 kilowatt and 375 must meet either the IE3 or the IE2 level, and they need to be equipped with a variable speed drive. Obviously, this is with a target to improve the demand and the usage of energy. Just to give you an example of an 11 kilowatt, that is, fairly common size for industrial application. An IE3 motor in continued use will almost save around 250 pounds per year than an IE1 model. So if we consider 20-year operating life of the motor, we can see that there is a very good convenience to go for the highest efficiency of the motor. We've got a case study here just to show, to give you some figures and some practical understanding of the efficiency of the motors. This case study is again coming from the Green Business Fund, and we've seen, we've studied, we have analyzed this client with two 37 kilowatt motor, and the absorbed power was, the load was around 85%, and this motor, those two motors were running for around 7,000 hours per year. The existing efficiency of the motor was 88%, and that corresponds to around 19.7k pounds per annum. By upgrading to an E3 motor, the two motor, we've got the efficiency went from the 88% to the 93.6%, allowing to save 2 times by around 1,200 pounds per year. And the investment was fairly in line with market prices, so 7.5k, and given the Green Business Fund capital contribution by £975, the net payback, even in this case, was in the region of 2.3 years. That is a fairly good payback in the manufacturing sector. In addition to this, we have analyzed the life cycle cost of the motor, and also we've seen that we've compared a situation in which the first option was to rewind the motor at a cost of £800 each, versus an investment to buy a new motor. And projecting over a 10-year lifetime, we've got that just by upgrading, by replacing the motor to a more efficient one, the energy and the total cost over 10 years was around £10,000 less than rewinding the motor, the existing motor. Obviously, this is to say again that the life cycle cost of any equipment, especially of motor, is always very important to assess whether it's worth replacing the motor or just maybe repairing it. In addition to the equipment that you can install and you can fit into your energy systems or production systems, it is very important also to set or to improve or even to look at the implementation of energy motor management policy. Obviously, will structure your approach to repair and maintain your electric motor within the site. Obviously, a motor management policy, it needs a commitment from the senior management, and sometimes needs some resources from the planning and implementation areas of the company. Obviously, someone needs to take responsibility for it, and obviously it's again very important to review and to account for changes in price of electricity and new products available on the market to make the right evaluation and to see if most of the time it's worth upgrading the motor or just repairing it. Obviously, to do it, there are some activities that need to be done, like, for example, a schedule and of the motors that you've got on site, and also planning for potential purchase of new, more efficient motors. Also, a plan for repairing failed motors. To do this, obviously, as we've seen before, it could be very important to compare the life cycle course, and also to compare the two different scenarios, that is repairing or buying a new motor. And obviously it's very important to track all the changes and all the upgrades and all the failures that you've got amongst your motors on site. This obviously will lead to have a better control of your motors and to make efficient evaluations especially on the running cost of the motors. We can see that the decision is always depending on the application and the age of the motor and on the sides. We can see that usually low, small size motors tend to be replaced, just because like if a motor is smaller than 5.5 kilowatt, usually it should be replaced rather than repaired, unless it's a very new motor that has been running for less than a year. But usually it's more convenient to replace the motor. Usually, obviously, if you're going to replace the motor, you should go for the highest efficiency on the market, again, just to deliver the highest savings over the life cycle cost of the motor. And in case you're going to repair it, usually a typical motor should not be repaired more than twice, unless obviously there are case-by-case situation that needs to be assessed separately, but usually it should not be done twice on the same motor. There are some other energy saving actions that can be done to improve the efficiency of motors, electric motors. And one could be on the operating load of the motors. Usually it's good to avoid lights loading of motors. Modern motors, new motors, operate more efficiently above 50% loading, with a peak between usually 75, 80% and 90% load. Obviously, again, to determine the load, it's crucial to choose the right size for those motors, depending on your application. Power factor controllers are, again, energy saving device that during period when the motors is not very loaded, they can achieve between 1 and 3% savings. And this is typical in refrigeration compressors or cyclical loads and some stamping and pressing processes where there are iron losses. Another type of tape that can be assessed is the belt-driven pulley. Usually V-belts performance deteriorates by around 4% with age and with poor maintenance. Poor maintenance can add up to 5 to 10% deterioration of performance. Wedge and cocked wedge belts can maintain efficiency around 2, even 3% higher than standard V belts. Another thing that we can look at is the gear. Warm gearbox, which can deliver very high torque, has got efficiencies between 85 to 92%, compared with very good 98, 99% of new helical gearbox that might deliver lower torque. Now, we've seen what are the technical opportunities on electric motors. Now, I'm going to give you an overview of the Green Business Fund and how the Green Business Fund can help you implement some of those recommendations on electric motor and all the services that the Green Business Fund offers. The Green Business Fund is a scheme operated by the Carbon Trust to improve sustainability and energy efficiency in the UK. Currently, it serves small to medium-sized businesses in England, Scotland, and Wales, and it's been running for around 2 years, so it's still going to be running in 2018. Currently, the funding provides a combination of technical advice, training, and direct capital contribution for capital equipment. And there is scope for the funding for the fund to be expanded both in the UK and international, should additional funding be made available by a suitable body with the same purpose. As I say, it covers England, Scotland, and Wales. Small and medium-sized businesses, schools, sole traders, and charities can benefit from the scheme. The scheme is not supporting domestic properties, public sector, and new buildings. How does the GBF define an SME? Businesses that meet any of the two criteria that you can see on the slide qualify for this. So no more than 250 employees. The annual turnover must not be in excess of 25.9 million, and the annual balance sheet not in excess of 12.9 million. And no more than 25% is owned by an entity which does not meet the criteria, the above criteria. As I said before, the Green Business Fund, as part of the funding available, offers energy efficiency training. So this is delivered through workshops, usually 2-hour workshops around the country. Those workshops are hosted by Carbon Trust partners and delivered by the Carbon Trust, by ourselves. And the scope is to understand and to deliver some methodology to understand energy consumption, to identify no-cost and low-cost measures. And those workshops are for companies with less than 50 employees. And so far, we've trained around over 500 companies to date. You can see on the slide that there are some upcoming workshops, the 18th of April in Alton, 25th of April, 9th of May, and the 3rd of May. So you can see that the country is covered in many places: Eastleigh, Bath, and Cambridge. If you want to apply for these services, obviously any of those, you can go to the website, Carbon Trust website, and the dedicated area of the Green Business Fund, and you will find even more details. The other service that we offer under the Green Business Fund is the opportunity assessment. So essentially, depending on the level of spend of the organization, we offer a remote or on-site assessment. This energy audit is delivered by a Carbon Trust engineer, and the output of the audit is a short report, where you can see top 3 costed recommendations, and also the next step to actually achieve those savings. Under the opportunity assessment, we offer obviously a tailored appraisal of energy management approach, and as per scheme terms and conditions is available for SMEs in the countries where the scheme operates. Just to give you a case study of an energy audit we've done. This was for a manufacturing company that by implementing the recommendation we gave them, they could save £12,000 per year with a net payback of 2.7 years. So in most of cases, the recommendations are always coming with a good payback. Usually following the energy audit or just managing by itself, we offer the implementation advice service that essentially it's technical procurement and due diligence that we do for companies that qualify for the Green Business Fund. Essentially, we deliver impartial design advice, and also we can develop invitation to tender documents. We can select shortlist Carbon Trust accredited suppliers, and obviously once we've got the proposal, we carry out an independent review of the proposal. We offer up to 5 days support for this, and companies that should have already business cases for projects for energy savings ready for investment. The process is straightforward because we can select suppliers, and we can deal with them to achieve additional proposal. This is aimed at non-large companies up to £1,000 employees, again in qualifying geographies as per terms and conditions we mentioned before. Just a case study again. This was a lighting project that we went through the implementation advice, and was a sport hall, and again the payback was extremely good, 2.2 years with an investment of £8,000. That was even funded by the Carbon Trust capital contribution that we are seeing now. This is a non-refundable contribution of 50% of the project if the payback of the project is up to 5 years. If it's longer than 5 years, we still can provide some capital contribution, and we calculate this based on 50%, 5 times annual savings. And this is a straightforward project, as we deal with accredited suppliers, and we do once we've got the application for capital contribution from the accredited suppliers, we carry out financial verification and a technical assessment to confirm that everything is okay and everything is in line with high standards. This obviously it's a direct contribution to help most of cases the payback become more attractive. Apart from the Green Business Fund, and in Wales and Northern Ireland, we offer also, that can be combined with the Green Business Fund, the interest-free energy efficiency loans. This scheme is designed to support businesses with the same target, that is to upgrade to more energy efficiency equipment and renewables. It covers building technologies, as you can see, air conditioning, heating, cooling, heat recovery, and obviously lighting. Industrial processes, so compressed air, for example, motors, as we've seen before, heating, cooling for process, refrigeration, and variable speed drives, and also all renewables. These loans are available, as I say, in Wales. That could be companies can borrow between £3,000 and £200,000, and in Northern Ireland between £3,000 and £400,000. The concept is that the loan is offer is based on CO2 savings that a project can deliver. So we offer £1,000 for every 1.5 tons of CO2 saved annually. Obviously, we do once we've got the application. We do a sense check carried out by our engineers, and in most of cases we see that the monthly repayment is similar to the reduction in monthly energy bill, so the scheme works by itself. Loans are interest-free, unsecured, and have no setup fees. As I said before, businesses in Wales can apply for both free loans and Green Business Fund capital contribution that is capped currently at £5,000. If you need some more details, please go to the website carbontrust.com/Wales loans or NI for Northern Ireland, or you can just email us at loans@carbontrust.com, or you can give us a call on the number on the slide. One other important thing that we run as a Carbon Trust on behalf of the government is the energy technology list that, as you may be aware, can deliver some financial benefit to your organization. Organizations, obviously, that pay income or corporation tax can claim the ECA's allowances on purchases of ETL equipment. The ETL equipment is, if you go to the website that is showed on the slide, you can see that there are currently more than 60,000 products and spread into 57 technology categories. If you qualify for this, you can claim 100% of your purchase in the first year against taxable profit. Again, if you have any questions on the enhanced capital allowances, please send us an email on ecaquestions@carbontrust.co.uk, or you can go to the website to have some more details about the ETL program. Just to conclude this webinar, and I would like to let you know that we've got a directory on the website called Green Business Directory, that essentially it's a database of Carbon Trust accredited suppliers. So if you're looking to install some energy efficient or renewable technology, you might have some barriers like knowing which supplier you can trust, or how to choose the best supplier on the market, or you might not have time to assess all the options, or you just might want some technical advice from the supplier. You can go to the website, to the Carbon Trust Green Business Directory, and this tool is very easy to use. You can look for the technology you are aiming for, the area, you can look for the area the supplier covers, and obviously we can put you in touch with the supplier, or you can contact directly the supplier if you need, or if you want a proposal, or if you want to investigate some energy efficiency projects. These suppliers that are in the Green Business Directory obviously are used through the Green Business Fund when we go for the implementation advice. So thank you everyone for attending the webinar today on motors and drives. If you have, in the meantime, any other questions, please contact Green Business Fund at carbontrust.com or give us a call at 020-7832-4773. Thank you, everyone.